Thank you for tuning into my channel. Don't forget to click on like and subscribe if you like what you see and you would like to be notified about future videos. And in this networking lab demonstration, I have created a multi-tier VPC architecture illustrated by the diagram presented here. Here we have EC2 instances utilizing private IP addresses that have been deployed in 3 separate VPCs, each VPC having 2 private subnets that have been deployed into 2 different availability zones. And I will log into my VPC console and my AWS console to show you what I have here. Looking at my VPC dashboard, we see that I have 3 VPCs that have been deployed in the US East region: VPC-A, VPC-B, and VPC-C, with the following IPv4 CIDR ranges. These AWS VPCs allow us to create and manage isolated private networks within the Amazon Web Services cloud where resources can be deployed. I've also created 2 private subnets within each VPC. Each of these deployed into a different availability zone, as mentioned, to help protect applications from the failure of a single availability zone. Next, I created 3 internet gateways, one for each respective VPC. And these internet gateways allow communication between any instances that I've deployed into my VPCs and the public internet. Next, I have 3 route tables, and these route tables define the routing rules that will determine where network traffic is directed. Each of these have similar route tables that have been applied to the VPC and their subnets. Here you can see on the Routes tab, we have an example that any internet bound traffic that is destined to the public internet 0.0.0.0/0 is the default route that has been configured to route all of that traffic to a destination target of the internet gateway. Now, any outbound traffic that is routed to 10.0.0.0/16 will remain as traffic that is destined to the local network. And with these route tables being the main route tables for the VPCs, these route tables are going to be utilized by all of the different subnets within my VPCs, even though they have not been explicitly associated with the route tables. So in the event that I don't have a custom route table that is implemented for my subnets, then these default main route tables will be used in place. Next, we have the Elastic Compute Cloud, EC2. Looking at how many running instances I have available for Elastic Compute Cloud, we have an EC2 that has been deployed into each VPC of my AWS networks. These Elastic Compute Clouds, EC2s, are basically virtual machines that can be used for a variety of different purposes. Next, we have security groups. And we have security groups in place to control inbound and outbound traffic access to the resources that are deployed within the VPCs. The security groups act as firewalls that allow us to control this routing of traffic utilizing IP addresses, ports, and protocols. And as you can see, we have security groups in place that are allowing ICMP traffic into our VPC. Each VPC has an identical rule as well. Here is the EC2 security group for VPC-A. Allow ICMP traffic, any traffic, ICMP traffic that is sourced from 10.0.0.0/8 CIDR range. We also have security groups that have been created for VPC-B, allowing any traffic sourced from the 10 network for ICMP traffic. And finally, we have a similar rule that has been created for security group in VPC-C, and that's for allowing all ICMP traffic that has been sourced from any 10.0.0.0/8 network. Now, we do have default security groups that are created by default anytime we create a new VPC. Those are the security policies that apply to our EC2s in the event that we have not created any custom security group policies for our EC2 instances. However, in this case, I have created the custom security groups that I've just demonstrated previously. Next, I have created an IAM role that stands for Identity and Access Management. And this role and profile allow the Amazon Elastic Compute Cloud instance the permissions that it needs in order to be accessed using the session manager capabilities. As you can see under roles, this role has been applied to a specific profile. And this role is allowing the AWS service EC2, and it also combines session manager capabilities. And this role was assigned to the IAM profile of each EC2 instance. And back at our EC2 dashboard, we are going to test network connectivity between the different EC2s that we have deployed into our different VPCs. I am going to connect to each of my instances individually using the session manager option that has been enabled for me through the use of the IAM role profile. This allows us to connect without needing to utilize a key pair that we would normally create and utilize for connecting to an instance. This way we can use a connection directly through the web browser. So here is the EC2 that lives in VPC A. Next, I will connect to the EC2 within VPC B. And then finally, I will connect to our third instance that resides within VPCC. Okay, so from VPC-A, I will attempt to successfully ping test a connection to the EC2 that lives in VPC-B and VPCC. And let me grab those IP addresses. I am on VPC-A. We will go to the EC2 that lives on VPC-B. Copy. And we can see that's going nowhere, 100% packet loss. Let's try the EC2 that lives in VPCC. That test fails as well with 100% packet loss. Next, we will try ping connectivity testing from the VPCB. We will grab the private IP address of the instance that lives in VPC-A. We can see that fails as well. And then finally, we will attempt to ping by checking our network connectivity to the VPCC. As expected, this fails as well with 100% packet loss. Finally, we will test network connectivity from our final EC2 instance that lives in the VPCC. We'll go and grab the IP address, the private internal IP address of the VPC-A's EC2 instance. We'll go ahead and type in ping IP address. And that fails with 100% packet loss. And finally, we will attempt to ping the EC2 that lives in VPCB to check our access to network connectivity. We have ping. And that doesn't look like it's going anywhere either. Can you guess why the EC2 instances are unable to ping each other's private internal interfaces?